We'll be recording.
Yeah.
Somebody asked if we will be recording.
Yeah.
Because
You are happy with that?
Yeah, absolutely.
Okay.
Absolutely.
Shall we start?
Yeah, we can start.
Open Zoom. Good afternoon, everyone. My name is Noreen Durrani, and on behalf of Carceit, I warmly welcome you to today's seminar by our wonderful presenter, Gulbakhyt Sultanova, on a very under-researched topic. Gulbakhyt is representing Center for Pedagogical Measurement, and today she is sharing her research on non-cognitive skills among secondary school students in Kazakh medium schools, and she is comparing STEM students with non-STEM disciplines. Thank you very much, Gulbakhyt. We look forward to your talk.
Thank you so much. Thank you. Dear colleagues, thank you for coming to our research seminar. I know that everybody is pretty busy, and thank you for your time. And we hope to share something interesting for you, so you can also learn something new from our study. Once again, my name is Gulbakhyt Sultanova, and I am from the Center for Pedagogical Measurement. And before I begin, I would like to express my sincere gratitude to the Central Asian Research Center for Educational Innovation and Transformation. Yes, for organizing this event and inviting me as a speaker. Thank you, Mr. Rani, and Ms. Johnson. Thank you so much. Today I'm going to talk to you about non-cognitive skills and their role in Kazakh secondary education. These skills are increasingly recognized for their significant impact on student academic achievement and overall development. Building on this, Nurim and I, Nurim is my colleague and co-author of the paper. Nurim and I studied the case of Nazarbayev Intellectual School. Studied the case of Nazarbayev Intellectual Schools to find out whether there is a difference in the impact of non-cognitive skills on STEM and non-STEM subjects. After introducing you to the research idea, I'll announce the research questions and hypotheses, as well as describe the research model. Then I'll present the methods and the results of our empirical study. I'll conclude my presentation with the implications and limitations of this research and suggestions for further research. I'll be happy to answer your questions at the end of my talk. Let's oops, I have to use this one. Yeah, I've forgotten. Just a moment. Second. Please help me.
now you can.
Sorry. It's in this direction. This one. This one. Oh, this one.
Yeah.
Yes. Thank you. Let's start with a brief introduction to the research idea. Non-cognitive. Just a little bit not so comfortable, that's why I'll look in this direction. Non-cognitive skills, often called generic competencies, key competencies, and 21st century skills encompass personal attributes, social skills, and character traits that affect learning. It is well known now from many studies that non-cognitive skills are very important for student academic success, and sometimes even more important than cognitive skills. In secondary education, the ability of students to apply these skills greatly influences their academic performance. Especially in STEM education, distinguishing between STEM and non-STEM subjects is crucial for customizing teaching methods and assessment. Traditionally, STEM subjects focus on analytical thinking and problem solving, and non-STEM subjects emphasize more creativity and communication. However, there is limited research on the impact of these skills, non-cognitive skills, on academic achievement across different subjects. This study tries to fill that gap by exploring the impact of non-academic non-cognitive skills in academic achievement in STEM and non-STEM subjects using the skill framework developed for students of Nazarbayev intellectual schools. So this empirical research examines how non-cognitive skills differently affect academic achievement in STEM and non-STEM subjects as assessed by students themselves and their teachers. We formulated the following 3 questions. How does the direct effect of student self-assessment, the mediated effect of teacher assessment, the total effect of student self-assessment of non-cognitive skills differ between STEM and non-STEM subjects in influencing academic achievement? Building on previous research, this study expected to find varying effects of non-cognitive skills on academic achievement across 2 distinct contexts. And now let's move on to the next section where we discuss in more detail the approach and tools used in this study. This is the theoretical model for our study, based, as I said, based on the framework, on the skill framework developed by our colleagues in 2022, developed for NIS students. As we are using an established framework, the selection of specific skills and their distribution across 5 domains is beyond the scope of our study. So here you can see 26 non-cognitive skills categorized into 5 domains. Students assess their individual skills at the individual skill level, while teachers assess student skills on the broader domain level. In our model, we expected some skills, as assessed by students, will have direct impact on academic achievement, while other skills will have indirect impact on academic achievement. You can differentiate two types of impact. Looking at these solid lines, they represent direct effects, and dashed lines show indirect effects. In the case of indirect effects, student self-assessment impacts academic achievement via teachers' assessment. Let's take a look at the mathematical models. Equation 1 describes how direct effects of student self-assessment scores impact measured how measured the impact of student self-assessment scores on academic achievement. This is about direct effects. To investigate mediated effects, we use 2 equations. Equation 2 demonstrates how we explore the relationship between students' self-assessment scores and teacher scores, and equation 3 shows how we imaginated the relationship between teacher assessment scores and academic achievement. The mediated effects calculated as by multiplying the coefficients from equation 2 and equation 3. Total effect as sum of these two effects, direct and mediated effects, mathematically represented in equation 4. We used purposive sampling to survey all students from grade 7 to 12. A pilot study with 1,565 students was conducted in advance to ensure student survey's clarity. The final version available in Kazakh and Russian were administered across 21 schools in November 2023. The academic achievement data in math, physics, first language, and history were collected from school records at the end of December 2023. Here, I have to mention the following: that we excluded the data from one school from our analysis because this school uses different grading system, are not comparable with the grading system used in other schools. That's why we have only 20 schools, not 21 in our further analysis. We analyze the data from 795 teachers and 12,965 students across 20 schools using regression and mediation analysis. Mediation techniques. This study followed ethical guidelines ensuring informed consent and confidentiality. So let's move to the next. Let's move to the next part. Oh, sorry, I missed something here. Here, yeah, yes, sorry. It was here, there, here. So the analysis of data followed a four-step process. Firstly, we validated the data collection instruments using factor analysis for the student survey and inter-rater reliability for the teacher survey. Then we conducted regression analysis to find out direct effects of non-cognitive skills on academic achievement. Then after that, we implemented mediation analysis to investigate mediated indirect effects of these skills. The total effects as the sum of direct and mediated effects was calculated as our first step. The data were standardized with Z scores for consistency, and we used various R packages to conduct the data analysis. Now we move indeed to the next part and focus on the results of our study. Here you can see the descriptive statistics of the student survey data. According to student responses, scores of most skills range between 3.5 and 4, highlighting pretty high self-assessment of students, their own skills. Grid has the, you can see here, grid has the lowest average rate, while growth mindset stands out with the highest average rate. Standard deviations vary, with rule following skill showing the least variability, and growth mindset the most. Overall, students rate their skills highly on most skills except for In this table, you can see descriptive statistics for teacher survey data. First of all, mean score range between 7.7 for question 1 to 7.37 for question 5. With median scores slightly higher. The most frequent rating was 8, except for question 1, which had a mode of 7. A standard deviation indicated moderate variability, between 0.96 and 1.12. Scores ratings spanned between 1.33 and 9, with interquartile ranges close. All in all, teachers tended to rate students highly on most non-cognitive skills with moderate variability. Next. The validation of student scores showed that Cronbach's Alpha and McDonald's Omega were both 0.97, well above the 0.7 threshold. Exploratory factor analysis revealed 26 factors that account for 24% of the variance. Confirmatory factor analysis confirmed factorial validity of 5 domains. The validation of the teacher survey showed that Cronbach's Alpha and McDonald's Omega were both 0.95, also well above the 0.7 threshold, indicating strong reliability. The interclass correlation coefficient confirmed consistency among different raters. However, reliability varied by question. High for question 1, 2, and 4, moderate for question 3, and low for question 5. While low reliability for question 5 is a concern, we decided that gaining more insights and improving the understanding, the overall understanding of non-cognitive skills justifies the inclusion of question 5 in further analysis. And nevertheless, we also decided to focus on and report only the skills with estimates that significant at threshold stricter than 0.05. So this approach helps us to ensure that observed effects are reliable and not simply due to measurement errors. So in this table, you can see the estimates of the average direct effects. Effects of student self-assessment on academic achievement. Self-assessment is, of course, non-cognitive skills on academic achievement, not mediated by teacher's assessment. Here we can see that for STEM subjects, math and physics, information processing skill is a key driver to success, and this is here absolutely clear. However, we have plenty of skills. Those estimates are outlined in red with negative impacts on academic achievement. And here we can especially mention probably creative skill and leadership skill. So For non-STEM subjects, you can see we have pretty, I would say, many skills, statistically significant at this high level, and also all statistically significant estimates also all positive. And especially important for non-STEM subjects here, first language and history. I would say these three: responsibility management, rule following skill, and teamwork skill. Task management. Task management, rule following, and grid are three skills showing positive impacts in both contexts. The distinction in the direct effects of student self-assessment of non-cognitive skills on academic achievement is obvious here. And this distinction highlights that indeed different skills are important for academic success in STEM and non-STEM contexts. Here you can see the estimates of the average mediated effects, namely effects of student self-assessment mediated by teacher's assessment. And the analysis showed that most non-cognitive skills here have positive effects on academic achievement in all 4 subjects. And interestingly, in both contexts, the same set of skills shows the strongest positive impact. Here we can mention these 4 skills like leadership skill, teamwork skill, information processing skill, and responsibility management. Also interesting that mediated effects are consistently higher in STEM subjects, highlighting the importance of non-cognitive skills in analytical and problem-solving areas. 2 skills, capacity for optimism and growth mindset, do not impact academic achievement in any of the 4 subjects at any level of statistical significance. This implies that only in this context, teachers do not perceive these skills as critical contributors to academic success of the students. The similarity in the mediated effects suggests that educators widely value these skills for academic performance, independent from subject, and it is general across all subjects, all 4 subjects analyzed. Here you can see the estimates of the total effects, representing the overall impact of student self-assessment and teacher assessment of non-cognitive skills on academic achievement. The analysis of total effects shows that non-cognitive skills affect academic achievement in STEM and non-STEM subjects differently. Here we can see this difference also pretty clear. For STEM fields, information processing and grid are key to success, and still creative skill pose a challenge for STEM subjects. Non-STEM subject benefit here in non-STEM subject you can see all significant skills have positive impact on academic achievement. These 3 skills like responsibility management, teamwork skill, and rule following skill are especially beneficial for non-STEM subjects. Then we can conclude here that partners of total effects reflect the different demands and learning strategies that are needed for success in these different contexts, STEM and non-STEM subjects. In the next section, we will explore the implications and limitations of our study. First of all, I'd like to summarize our findings. We found the significant direct and total effects that vary by subject. In STEM subjects, information processing skill and grit positively impact performance, while creativity shows negative effects. In non-STEM subjects, most non-cognitive skills have positive effects. Responsibility management, rule-following skill, and team work skill demonstrate highest positive effects. Team management, rule-following skill, and grit show positive effects in both contexts. Now to mediated effects. These effects are more consistent across subjects. Most non-cognitive skills have positive impact in both STEM and non-STEM domains. Leadership skill, teamwork skill, responsibility management, and information processing skill demonstrate the strongest positive effect in all subjects. And of course, future research is needed to before drawing any definitive conclusion. However, it is clear that teachers' assessment plays a crucial role in shaping the influence of non-cognitive skills on academic achievements. Our study has some important implications for research and practice. Our research confirmed that teachers' evaluations are key in applying non-cognitive skills, and this underscores the need to redesign teacher education and professional development programs so that they can learn to develop assessment tools that assess non-cognitive skills and integrate these assessment tools also in the educational process and in the class their classrooms. Combining frameworks for generic and subject-specific skills can also help improve assessment practices, while supporting social emotional learning and teacher development can support non-cognitive initiatives. Anyway, student assessments are very important, and first of all, because they help us to understand how students perceive their own non-cognitive skills, and their perception and these non-cognitive skills, all in all, they help foster their academic and personal growth. Of course, the more sources of information for assessment, the better. If we combine student self-assessment, teacher evaluation, and let's say peer feedback, this approach can offer more comprehensive understanding, increase assessment accuracy, and also help us develop targeted interventions. There are some limitations of our research and suggestions for further research. The study's cross-sectional nature limits our ability to make causal inferences, and mediation analysis suggests some pathways. Yeah, and we know these pathways from our study. However, only longitudinal studies can help us to confirm these pathways. Non-cognitive skills were evaluated by teachers, and this evaluation is well known as a good one, accurate one. Nevertheless, this evaluation can also miss some nuances. Of course, using diverse assessment methods can help improve the outcomes, and this can be also realized in future research. Uncontrolled factors like family background and peer influences can affect the outcomes of future studies. Then also adding other non-cognitive skills or excluding some non-cognitive skills from what we have right now. Again, we're using an established existing framework, can also give more insights. And of course, the findings of our study also limited by our sample, which is pretty specific. It is about Nazarbayev intellectual school students, very talented in STEM subjects and best selected from whole country. That's why, of course, this sample is very specific. And checking how it works, this approach in other cultural and educational settings can help generalize the findings of our studies. So let's summarize what has been said. In this study, we investigated how student self-assessment and teacher assessment of non-cognitive skills affect academic performance in STEM and non-STEM subjects. Analyzing large-scale data from 20 schools in 2 STEM and 2 non-STEM subjects, we found significant direct and total effects varied by subject, and mediated effects more consistent across subjects. This is the first comprehensive study about non-cognitive skills impact in STEM secondary education in Kazakhstan. And future research should examine how these skills interact with other cultural contexts, and also longitudinal studies and intervention studies will be helpful for developing further this approach. And the findings of our study are important for shaping equitable education policies and promoting a holistic approach to student development. Dear colleagues, that's all for now. Thank you so much for your attention, and we would appreciate your comments, questions, feedback, anything.
Thank you so much. There is a lot for us to digest, and it's a quantitative study. Many of us, like myself, might need a bit of discussion just to digest not only the findings, but the methodology behind the findings. So I'll just give you a couple of minutes to discuss what you have taken away from this talk. What do you think surprised you? What perplexed you in terms of, a lot was shared about moving forward in terms of research. What other kind of research you might want to go ahead with, and what particular question you might want to ask or feedback you might want to provide Gulbakhyt. Okay, so take a couple of minutes. Feel free to discuss, and then we will open the floor for questions and answers. I just it was very well planned. Thank you very much. Covered so much.
I was trying to say 30 minutes, and I tried to get it.
It means you will have more questions now, more time for questions.
Yeah, yes. Any questions? Yes, if we decide, oh, yes. Here, based on
We do have quantitative research. I understood. I'm not an advanced quantitative researcher, but I kind of understood what you mentioned. I just didn't want people to feel they might not be the only one who found it hard. So that's why I said, yeah. Oh, you've already published. Yes.
And oh, forgot to mention this. And I think when we start our discussion part, I will also find few minutes to mention.
Yeah, we can say that now. It's displayed as well. So, yeah. When was it published? Okay, congratulations. Paper. Okay. I mean, I will ask you, you don't have to answer now, but as someone who has interest in general, I wonder within the study if we also looked at differences across women and boys and men and women.
Yeah, there are some differences, some of the skills, but we haven't, included this publication, but we hope that this will be our next step.
That will make it even more interesting.
Because of this, one I think it's 3 by 26. This published on 28 pages. 28 pages. Yeah, pretty much for one article. And that's why we thought, okay, let's do something also later on. Maybe focus on the gender issues because it is really important.
Yeah. Great. But I will ask you that question so everyone knows the answer.
Absolutely. Yeah, thank you so much.
Have a discussion. Can we ask the presenter to move to the declaration framework?
Yes, okay.
Okay.
The factors, yeah.
Yeah.
Yes.
One.
Yeah.
Any questions? Just please. Here you cannot ask something what is not interesting. Everything is interesting for us.
So thank you very much. You were shown a slide where the full paper is, the published paper is available for free download. So you are welcome to look at the full paper. But this is an ongoing research, and both Gulbakhyt and Nuram, they are interested in further developing their research in this area. So although the paper is published, this feedback is still very, very valuable for both our visitors today and guest speakers. So yes, we have a question over there.
Yeah, we're discussing. Thank you very much for this entire presentation. Maybe we in the beginning some kind of missed when you explained it. Just wanted to ask you elaborate on this framework. So we understood that in teacher service, students assess themselves. their skills. And here, teachers are self-assessed
Students.
So
Yeah.
in this regard, my question is, what was the theory or rationale behind putting them as a mediating effect between actual results that their assessment, the rationale or theory behind putting as a mediated effect? How does student assessment actually affect between this relationship between student self-evaluation and their academic achievements?
After looking at main sources like theoretical papers, and also empirical papers on this issue, we decided to focus on what we have from our statistics. It was so that our students' scores, they correlated very weak with academic achievement. And of course we did some homework with producing correlation tables, and we found out that student scores are not correlated but teacher scores correlated, and that's why it was clear for us to put teachers closer to academic achievement, because otherwise we cannot explain on everything. And then we also correlated these two survey scores, students and teachers, and found out that they correlated on average, I would say like 20%. And interestingly, also students they think I'm good at these particular skills, and teacher see them our students good at other skills, and that's why it is only 20%. And then we also found this approach, mediation analysis, and decided to use this referring to our statistical data, and statistical analysis first we did, and our first paper published in Franchise and Education, it was so we combined these two, students and teachers scores into one composite score, and also looked how this composite score affect academic achievement, and we have a little bit different outcomes, but in general the same situation with information processing skill, always best skill for STEM subject, and always we have the issue with creative skill, whatever we do, combine or make them different from each other. And the second approach, we decided for the second approach because teachers answered only 5 questions, at this domain level. It means all these skills included in this domain, and
One question, just one question.
just one question, yeah. Why? Because each teacher answered on average, assessed on average 50 students. That's why it was too much burden for our teachers, and we decided to keep this approach with only 5 questions at domain level. That's why, of course, it will be nice, and we are going to suggest this to have to extend our questionnaire for teachers, covering all 26 fields separately. But again, can you imagine a teacher who should answer 26 questions?
For each student.
Yes, and 50 students on average. We have somewhere like 90 students per one teacher. I hope it helps a little bit.
Let me just add something to this. Thank you for your question. And the student assessment is just one instrument, and it might be a bit biased. That's why the teacher assessment is a form of a validation of the instruments. That's why we took this approach.
So when you are comparing, you are just taking that one question that is similar between teacher survey and student survey, because, you know, I'm just thinking, you know, if teachers just answered for domain one only one question, but students actually answered 7 questions, you are comparing only the one that is similar across the 2 surveys.
Yes.
Yeah.
Otherwise, it is
Yeah.
too much work for
Yeah.
our really involved teaching staff.
So while Jerry has a question. Yes.
Just, I mean, I'm not very good at this, but when you're talking about mediation, you're supposed to do like tests to decide if it's, you know, does the mediating variable explain significantly more than direct variable? Is it like partially mediated, that kind of stuff?
Mhm.
Then you have to account for that. So